One of the most important topics in photography is focusing, and the reason why is because you want your subjects to appear sharp or in focus in your images. Now, you might have your pet or your child running towards you, or perhaps you're sitting in a very dim environment where your camera is struggling with acquiring focus. Well, all that has to do with focusing, and the biggest frustration is when you grab that brand new camera and you start taking pictures and all of a sudden you see these blurry images as a result of badly focused images. Now, this section is about autofocus, and I want to talk about all the different autofocus modes that you have in the camera and discuss that in detail so that you can utilize those different modes to get the best results. So if you're photographing, say, a blue sky that has no texture, no clouds, or maybe a plain white wall, you might see that your camera is going to struggle. It's going to go back and forth trying to acquire focus, and then at the end it will give up. Now, the reason why it happens is because your camera is looking for a contrasty area that it can use in order to be able to acquire proper focus. Now, what is contrast? If you look here, we have two boxes. One is white and one is black. Now, you can see the white area itself has no contrast, it's just plain white. And the black area is also without contrast, it's just pure black. If you put your camera and try to focus in these two separate boxes, your camera will fail. It will not be able to find anything to focus on. However, that division that you see in between, that line, that where the white is crossing the black, is the area of contrast. So if you move your focus point in the camera to that area and you try to focus, your camera will be able to snap into focus immediately. So when you think of contrast this way. You have to have something, a texture, maybe differences in colors, something that your camera can use in order to be able to tell whether the subject is going to be in focus or not. So replace that plain sky with a sky with clouds and then focus between the clouds and the sky, and all of a sudden everything is going to look great and in focus. And the same with a plain white wall, where you put maybe a frame, a picture, and you focus right in the edge of that frame, and your camera will be able to snap into focus perfectly. Now, I just mentioned that there are different focus points that you can use in your camera, and that's the nice thing about focus systems, is that most of the modern cameras today have lots of focus points for you to use. And what you can do is, instead of using that center focus point all the time, you can actually move it around in the frame, and maybe if your subject is off the center, you can have the camera track that subject movement away from the center of the camera. Now, when you do that, it's important to understand that some of the focus points are going to have more or less features than others. For example, the one that's in the center is usually the most sensitive one. It receives the most amount of light and also is of something called a cross-type sensor. Now, what a cross-type sensor does is basically looking for both vertical and horizontal contrast, whereas regular focus points are called vertical points. They're basically looking only for horizontal contrast. So that's something to keep in mind. If you want the most accurate focus points, they're usually going to be located either right there in the center or maybe the center and the surrounding focus points in the frame. Now I want to talk about the different passive autofocus systems. There are basically three different types. There's phase detection autofocus, there's contrast detection autofocus, and then there's hybrid autofocus. Now, in your DSLR, things are going to work a little bit differently than, say, on a mirrorless camera. And the reason why is because the DSLR relies on a mirror. Now remember, within the DSLR, the light passes through the lens, and then once it gets to the camera chamber, there is a mirror that's situated there at a 45-degree angle, and the light basically bounces through that mirror up into the pentaprism and then ends up in the viewfinder, and that's how you see through the lens in your camera. Now, what you might not realize is that the mirror there is actually semi-translucent. So there's a portion of the area of that mirror that actually lets some of that light through. And right behind that mirror, there is a secondary mirror. And the purpose of the secondary mirror is to bounce some of that light down into the camera chamber for a separate autofocus sensor. And that type of autofocusing is called phase detection autofocus. Now, I'm not going to go into technical details about how phase detection autofocus works, but basically there are two sensors located away from each other, and they're basically looking at light at two different angles. And what happens is, if the light converges in the same area at the same point, then the subject is in focus. If it doesn't, then the camera knows that the subject is not in focus, and it instructs the lens. So there's that back and forth communication between the camera and the lens happening until the subject is in focus. Now, contrast detection autofocus is typically going to be slower than phase detection autofocus, and the reason why is because the camera basically needs to probe a certain area to find the area that has the most amount of contrast. That's why when you use a contrast detection autofocus, like for example on your iPhone or on a point and shoot camera, what's going to happen, the camera is going to probe back and forth and then stop at a point where it has the most amount of contrast. Now, if you're photographing action, you are always better off photographing with phase detection autofocus. And the reason why is because phase detection can actually acquire focus faster and it can track subjects better than contrast detection. But it doesn't mean that contrast detection is any worse than phase detection. So for example, if you're shooting a landscape, well, you don't have anything actively moving in the frame. What you can do is you can actually switch to live view on a DSLR or just use the screen on the back of the LCD on a mirrorless camera just simply to point to the area where you want to focus. And you don't need to use the phase detection. You can actually zoom in to a particular area of the frame and make sure that whatever you're trying to photograph is critically sharp. So keep this in mind when you're out shooting. There might be use for both phase detection autofocus and contrast detection autofocus depending on what you're trying to do. Let's now talk about hybrid autofocus, and this one is really easy because it's a combination of phase detection and contrast detection. Now, on mirrorless cameras, remember that the sensors are located directly on the digital imaging sensor. So you can basically switch from phase detection to contrast detection by either turning phase detection off within the camera menu, or what you can do is when you switch to a low light environment and the camera doesn't receive enough light, these mirrorless cameras usually automatically switch to contrast detection. So that capability to automatically switch between phase detection and contrast detection is simply called hybrid autofocus. Alright, so we just talked about phase detection, contrast detection, and hybrid autofocus. Now let's talk about the different autofocus features that you might have in your camera. Now you have to realize that when manufacturers make cameras, they make them at different price point and different feature sets for different markets and levels. So for example, there are entry-level cameras, and then there's enthusiast level cameras, and then there are professional level cameras. Those three might have completely different feature sets when it comes to autofocus, when it comes to the buttons and other things that you can access through menus, and also when it comes to image quality. So if you look at an entry-level DSLR, you might see that it only has 9 focus points and only one cross type that's located in the center. And if you look at higher-end cameras, maybe enthusiast level or professional, you might have something like 39 points or 51 points or even more. And you might find on the highest-end systems, even all the focus points could be cross type. So that's something for you to keep in mind when you look at different level cameras. Whether you're looking at entry level or enthusiast level or professional level, they're going to differ in a lot of the features, especially autofocus. So these higher end autofocus systems that have a lot more cross-type focus points and maybe have a lot more features, they're designed this way to accommodate for more demanding applications. So for specific types of photography like sports photography, any type of action photography where the subject moves drastically and very quickly, in those environments, the higher end autofocus systems are going to be a lot more suitable. They're going to be faster and they're going to be a lot more accurate. So I mentioned autofocus speed, and there are 2 variables that directly impact that. You've got the actual autofocus system in the camera itself, and then there's a focus motor that's built into lenses. Now there's something important to keep in mind there, is that if you grab, say, an entry-level kit lens, it's probably not going to have a very fast autofocus motor. That's just the way that those lenses are built. They're not designed for really demanding applications. Whereas a higher-end pro-level lens, which is going to cost a lot more, is probably going to have a much quicker autofocus motor built into that lens, so that when you couple it with a higher-end autofocus system, it's going to give you incredible results. This means that focus motors inside lenses are not created equal. You might have 2 lenses that you're looking at and say they're 10 years apart. Well, the older one is probably going to be slower, louder, and less accurate than the newer generation lens. And that's something that you should expect when looking at lenses. Alright, let's now talk about the different autofocus modes. But before I get there, let me first talk about the AF area mode, or in the Canon world it's called AF point selection. Now, what is AF area mode? When you're looking through the viewfinder, whether it's an optical viewfinder or maybe an electronic viewfinder, you have these little dots or squares that basically designate the focus point. And when you move that around, you're basically telling the camera, wherever I move this focus point, you need to focus in that area. Now, going back to that square example where we had two squares, the white one and the black one, where the contrast area is right there in the center, if you take that focus point and put it right there in the center, the camera is going to detect contrast and it's going to be able to focus. But what happens if you move that single focus point in, say, in the middle of the white area or in the middle of the black area? Well, there is no contrast and the camera is going to go back and forth. It will not be able to acquire that contrast and find the focus, and it's going to hunt, and eventually it will give up. But what happens if you choose, say, multiple focus points, which is another option that you have in the camera? In that situation, you're basically telling the camera, well, use this group, which might be a combination of maybe 5 focus points or 9 focus points or even more. And what you're telling it, you're saying, I'm going to give you the flexibility to basically choose within these 9 focus points, for example, to find the area that has the best contrast and use any of the 9 focus points to focus on the subject. So in the example of the white and the black square that we're talking about, if you activate all those focus points in the group and you basically put that in the area where the line is being crossed, even if some of the focus points are going to be in the black area or the white area, as long as some of them cross that line, the camera will know, well, I can't detect focus in any of these, but there are some of them that cross in between, and is going to use those particular focus points to acquire focus. Another option is to activate all the focus points, where you're telling the camera, well, I don't want to choose a particular area to focus on, just activate all the focus points that are available and try to find contrast. Now, in this example with the black and white boxes, well, if you move the group focus points to one side of the frame and they're no longer crossing that line, the camera will still not be able to acquire focus. But by activating all the focus points at the same time, then the camera is basically utilizing that entire frame coverage for the focus points, and then it will detect that there is a line in there and use the appropriate focus points that are located in that division to be able to acquire focus. Now, if you're photographing a person, for example, you might have face recognition turned on in some cameras. And what will happen is the camera might then recognize skin tones and even use one of the focus points to acquire focus on the nearest eye of the person. So that's something that is going to vary by camera. If you do have face recognition, you might want to turn that on before you activate all those focus points, and it might simplify the focusing for you. So to summarize, you could have a single focus point selected in your camera, which is basically telling your camera to only focus using that one focus point. You could have multiple focus points selected in a group, or you could have all the focus points activated at the same time. Now, we're going to come back to this shortly, because what makes it a little bit more complex in autofocus is that in different autofocus modes, the AF area mode actually behaves slightly differently. So let's now talk about the autofocus modes and how that impacts the AF area mode. No matter what you're shooting with today, whether it's a DSLR camera or a mirrorless camera, you're going to have a few autofocus modes available for you to choose from. We're going to talk about the 3 main ones today, but there might be more available for you depending on what camera you're shooting with. Now, the first one that we want to talk about, in the Nikon world, it's called single area AF mode, and in the Canon world, it's called one-shot AF. Now, what is this one-shot AF or single area AF mode? In this mode, once your camera acquires focus on your subject, it basically locks the focus. So if your subject moves, it's not going to require that focus. And this mode is great for using, say, for photographing landscapes, architecture, or photographing people that are posing for you and they're not moving. Now, what's important to keep in mind is that if your camera cannot properly acquire focus, say you're photographing in a very low contrast environment, or maybe you have a very low light environment and the camera is just continuing to hunt for focus, what's going to happen is when you squeeze that shutter, the camera will refuse to fire. Now, that's the default behavior you see on pretty much every camera. On an entry-level camera, that's basically something you're stuck with. On a more advanced camera, you might have a menu option in the camera that will say something like AFS priority selection or maybe release priority on Canons. And in those situations, you can actually go into the camera menu and override that behavior. You could say, instead of choosing focus as the priority, set release as the priority. priority. Once you do that, whether the focus is acquired or not, the camera will still allow you to shoot. Another option for you when you're shooting in a very dim environment and your subject is simply not getting enough light for autofocus to function properly is to actually cast a beam of light on your subject. Well, you can do that with the AF assist lamp that's available on your camera. But one thing to keep in mind is that this AF assist lamp will only trigger when you're in single autofocus mode. It will not work in any other autofocus mode. Now, how do those AF area modes work in this single autofocus mode? Now, if you remember, if you choose a single autofocus point and the camera is only using that one point to acquire focus, in this mode, the camera is simply going to acquire focus once and will never reacquire focus again until you retrigger that focusing mechanism. If you're doing multiple points, then it's going to seek for contrast, find maybe one or more focus points to use, and it's only gonna do it once again. And the same with all the autofocus points. So the behavior is the default behavior, which is to find what to focus on, and once it locks on, not change it. Now, what if you're photographing someone who's actually moving? Perhaps you're photographing a pet or your child running towards you, or you're photographing any sort of action. Well, the single autofocus mode is not going to work because it only acquires focus once, and you need to be able to track the movement of the subject. So what you do then is you can switch to a different focusing mode, and it's called continuous autofocus mode. So the continuous mode, depending on what camera you're using, might be called differently. In Nikon's world, it's called continuous AF mode or AFC. In Canon's world, it's going to be called something like AI servo. Now, both do basically the same thing, which is to track your subject and reacquire focus continuously. So when you have pressed that shutter release, or if you maybe have focusing on a different button on the back of the camera, when you continue holding that button, it will continuously try to focus on your subject. Once the focus locks on, if your subject moves, it will reacquire focus. Hence, continuous autofocus mode is a lot more complex and versatile compared to the single autofocus mode. Now, how does continuous autofocus mode impact the AF area modes that we talked about earlier? If you select a single focus point, say when you're photographing that pet or your child running towards you, well, the child or the pet are probably not going to go left and right. They're going to go straight at you, and your camera is pointed directly at the subject. Well, in that situation, you might just pick one focus point to basically focus on. And what's going to happen is, as you select that one focus point, the camera is going to automatically track any movement within just that one focus point. But what if you're photographing a bird taking off, or maybe any sort of movement? Maybe you're photographing planes flying by. What you're going to do in those situations is you do not want a single focus point, because you cannot guarantee that you're going to be able to keep up with the subject just with that one focus point. What you want to do in those cases is you select more focus points. So in this case, you could do a group where you are selecting maybe a total of 5 or maybe 9 or more focus points, and what you're telling the camera is, well, I don't know exactly where this is going to end up focusing. My subject is approximately in that area, so use any of those focus points to track the subject. And when the subject is moving, say a bird is taking off, as long as those focus points that you selected in that group are roughly in the area where the bird is, the camera is going to be smart enough to be able to track the movement automatically and continuously track the subject. Or if you're in an environment where you have no idea where the subject might be coming out of, then you might want to actually activate all the focus points. And by doing that, you're basically telling the camera, look, I have no idea where exactly you need to focus, but I have all this movement happening, so find the best subject to focus on and just continuously track it. Now, that mode can be really great to use in some situations. For example, when I was photographing lots of birds taking off and flying towards me, I had so many birds, and there's probably thousands of them, and they're all taking off at the same time, flying towards me. I can't really say, well, I'm going to just choose that one bird in the flock and just focus on that bird. In that situation, I didn't care. I just wanted some birds in focus as they're flying over me, and maybe just find one bird to track on and just keep that focus locked on that one bird. So what I did was I selected all the autofocus points to get activated, and as that flock was flying towards me, the camera did that focusing for me. I didn't have to deal with a single point, a group of points. I just let all the autofocus points be active at the same time. So there is use for all three of those modes. Just keep that in mind. And when you're going through these different modes, whether you're selecting continuous autofocus or single autofocus mode, it's important to keep in mind that one point, multiple points, or all the points can be useful depending on what you're trying to do. The last autofocus mode I want to talk about is a hybrid mode, which is basically a combination of the first two modes. Now, in the Nikon world, it's called AFA. In the Canon world, it's called AI Focus AF. And what it is basically it's looking at your subject. If the subject is not moving, it's in that single autofocus mode. It switches to that automatically. But once your subject starts to move, the camera is smart enough to switch to continuous autofocus mode. So if you're struggling which autofocus mode to choose, this mode might actually work for you. But just keep something in mind. Although this mode tries to be the best of the two worlds between the single autofocus mode and the continuous autofocus mode, if you're doing something specific like photographing birds, for example, then it might actually be slower in comparison. So what I would do is just learn how to use each mode individually. Now, how do you change your autofocus mode in your camera? And this is where it gets a little bit more complex because with every camera maker, they put it in different places. On this Nikon D5200, for example, I have to press the info button and then go into the menu and basically select that I want to shoot in AFS or AFC, which is the single autofocus or continuous autofocus, or maybe the AFA, which is that hybrid mode that I was talking about. On higher end cameras, you're going to have a dedicated button on the camera that you can basically press and then you cycle through those modes. On Canon cameras, for example, you might have a button on the top of the camera that you have to press and then you use one of the dials to be able to cycle through the different modes.
It's a cold day here in Denver, but what better way to stay warm than going for a jog or riding a bike? So today we're going to talk about autofocus and have Melissa here do a little exercise just to demonstrate the different autofocus modes. I'm going to have Melissa go over here and move towards me. Both times I'm going to shoot in the continuous release mode, so as I hold the button down, it's going to just take photos as she moves towards me the entire time. The first time we're going to start with her walking towards me and I'm going to use just the single focus mode. So go ahead and go over here. I'm going to step back a little bit and go ahead and just walk towards me here. Okay, now looking back at these, the focus didn't change a bit. The first photo's in focus, the rest are out of focus. That's because when it gained the focus, especially in the continuous shooting mode, it never reacquired focus as she moved towards me. So we're going to do it again, but we're going to change to a continuous focusing mode and see what kind of a difference that makes. So go ahead and go over here. And just to really test things out, I'm going to have her jog towards me. So enough of this walking stuff. We're going to have her jog, a faster moving subject. Let's see how the camera does. So, are you ready? All right, go ahead, come on towards me. All right, got pretty close there. And looking back, so much better. Almost every single photo, actually maybe every single photo is in focus. So it tracked the moving subject, a fast moving subject, gave me great sharp photos. Now that you know about the different autofocus modes and the different autofocus area modes that you can choose, I'm going to give you some focusing techniques that you can use in different situations and different scenarios to get properly focused images. One of the most frustrating situations a photographer can work in is a low light situation. When you're in a low light situation, there's not a lot of light for your camera to work with, and we already know that your camera's autofocus system needs light in order to properly attain focus. Now, of course, you can always change your ISO, you can open up your aperture, you can slow down your shutter speed, and that lets more light into your camera for your exposure, but those have no effect on how your autofocus system works. So what can you do? Well, the first thing you can do is just simply move to an area that has more light. If you're indoors, you can move closer to a window or maybe to a more well-lit room, or if you can, go outside, because any camera is going to be able to focus in daylight. If you're in a daylight environment like I am right now, a camera is not going to have problems autofocusing on a subject simply because there's so much light available. When you're indoors, the amount of light available is going to be drastically decreased, especially if it's a darker room without many windows. If you're only relying on overhead lights or lamps, there's not a lot of light for your camera to work with. So the first thing that you can do is just move to a better lit area. If that's not an option, you can also use your camera's built-in AF assist lamp. but that's not always going to work. First off, it's not a very powerful lamp, so you have to be very close to your subject for it to work. If you're photographing someone across the room, forget about it, it's not going to work. It's also kind of annoying because you're flashing light on your subject, and if you're photographing something like a wedding or an event where there's an ambiance, people are watching your subject and you're constantly flashing this light on them, it's kind of going to ruin the mood, and it's really not the best solution. So, what else can you do besides that? The first thing you can do, and this is the best option for any low light environment, is to choose the center focus point. Why is that? Well, the center focus point receives the most light coming through the lens, and that's always going to be the case, but it's also always going to be a cross-type sensor. So not only is it receiving a lot of light, but it has the best chance at finding contrast in your scene and locking focus on your subject. So regardless of what you're shooting, if you're in a low light situation, choose that center focus point. Another thing you can do is change your autofocus area mode to just a single focus point. If you're using a group of focus points or all the focus points, your camera might not actually be using that center focus point and instead is using less accurate focus points than the center. So if you change to just a single focus point and make sure it's the center one, you're guaranteed to use that most accurate focus point every single time. Now keep in mind, these previous two tips I gave you have to do with your camera's phase detection autofocus system. But if that's not working for you, you can always switch to a contrast detection autofocus system, which is found in live view. Now in a DSLR, you'll switch to live view, but the trick is going to be you can't use your optical viewfinder anymore. You have to use the screen on the back of your camera. When you do that, you're actually going to be holding your camera away from your body a little bit to see the screen, and that could possibly introduce camera shake because you're probably shooting at lower shutter speeds. So make sure if you do use live view to focus, you'll probably get more accurate focus in low light situations, but you want to make sure that you stabilize your camera either by sitting on a tripod or on something solid like a table. Now that only applies to DSLRs. On a mirrorless system, it actually is going to switch from phase detection to contrast detection automatically if there's not enough light for the phase detection to work. Another bonus for mirrorless is that the viewfinder is not an optical viewfinder, but it's an electronic viewfinder, so you don't have to look at the back screen on your camera. You can still look through the viewfinder and get the benefits of contrast detection autofocus. Now another benefit to mirrorless is that you can have the option for it to zoom in to 100% in the electronic viewfinder so that you can make sure that the focus on your subject, even if you're in a low light environment, is tack sharp before you take the photo. If you're shooting in a single autofocus mode and there is simply not enough light for your autofocus to lock onto your subject, chances are it's not going to take any photos and you're going to walk away empty-handed. So this is a last resort, but it's better than having no photos at all. If your camera has it, check your menu settings and see if you can change your release priority from focus to release, which means that when you push the shutter button, even if your camera does not lock focus, it's still going to take photos. If your camera doesn't have the option to change the release priority for single autofocus mode, change over to continuous autofocus mode because that is typically going to be set to release instead of focus, and at least you'll get some images from whatever you're photographing. One focusing technique that I use all the time, and lots of other people do as well, is called focus and recompose. Now when you focus and recompose, it's exactly how it sounds. You attain focus on your subject, you recompose the image, and then you go ahead and take your shot. When you focus and recompose, there's a few steps involved that you'll need to do. So the first thing is to take your active focus point or points and put them on the part of your subject that you want to be in focus. You'll half press the shutter button so that your focus locks on that part of your subject. Now, holding it down the entire time without taking a picture yet, you'll recompose your image so that your subject falls within your frame wherever you want them to be. And finally, you'll go ahead and fully press the shutter button to take the image. Now this works great in a single autofocus mode because once your camera acquires focus, it locks it. And even if your subject or if you move, it's not going to refocus. Therefore, you can recompose and your subject will stay in focus the entire time. Now this really doesn't work with a continuous focusing mode. And that is because when you acquire focus in a continuous focusing mode and you recompose your image, well, your focus points have just moved off of your subject and your camera is going to try and acquire focus on something else, and that makes your subject out of focus. So it's not really possible to use this technique in a continuous focusing mode. But there is a trick that you can use in your camera so that you can still focus and recompose in any autofocusing technique, and that is called back button focusing. So what is back button focusing? Well, just like focus and recompose works exactly the way it sounds, so does back button focusing. You just focus with the button on the back of your camera instead of your shutter button. Now, pretty much every camera today has a button on the back that you can program to perform a certain function. They'll usually come by default set to do one thing, but look in your menus and there's probably a way you can set it to perform the focusing function. So why would you want to do this? Well, when you take away the focus from your shutter button and put it on the back of your camera, then your shutter button will no longer acquire focus, it will only act as a shutter button. So once you lock your focus using the back button on your camera, no matter what you do up here until you fully press the button, you're not going to take a photo. So the trick here, the way you can use it with a continuous focusing mode is you press the back button to lock focus. You let go, focus stays locked, and as soon as you're ready to take the photo, you can go ahead and push the shutter button. Your image gets created, composed exactly the way you'd like it to be. So does this mean that you can't use back button focusing in a continuous autofocus mode to track a moving subject? Of course not. All you have to do is hold down that back button and a moving subject is going to get tracked by your autofocus system just the same way as if you're half pressing your shutter button. So why would you want to use back button focusing with a continuous autofocus mode? Well, let's say for example you're photographing a bird and it's flying around, so you're holding down the back button and your camera's tracking it and focusing on it the entire time it's moving. Well, once it lands, you don't really want to sit there holding down the back button the entire time that it's sitting there because A, your camera is looking for movement and it's trying to focus the entire time, and B, your thumb's going to get pretty tired. So once it lands, your camera's focused, you can take your thumb off the button and your focus is locked. That bird's not moving, there's no need to reacquire focus. You can go ahead and take photos if you want to. Pressing the shutter button doesn't change the focus a bit. So you can see one benefit right there is it saves your thumb from getting tired. But then, once the bird takes off, you just push the button again, it's right back onto focusing on that bird, and you're shooting away. So back button focusing is simply shifting the focusing function away from your shutter button to a dedicated button on the back of your camera. And when you do this, the button on the back of your camera only works for focusing, and your shutter button only works for triggering the shutter. And this is really, really great because sometimes when you're trying to acquire focus, you accidentally take a picture, and sometimes when you're trying to take a picture, you'll change your focus. This way, there's one button for focusing, one button for taking a picture. So if you haven't given it a try, figure out how to do it in your camera, set it up, and give it a shot. It's a really great technique to use. When you're focusing on your subject, there are 3 different ways that you can check to see if your subject is in focus before you take the image. You can look through your viewfinder, and that viewfinder is either going to be an optical viewfinder or an electronic viewfinder, or you can use live view. We're going to discuss those 3 different options and the pros and cons to each one. With an optical viewfinder, you're seeing through your camera's optics, so you're seeing the light that comes through your lens and out your camera's viewfinder. And that's great for seeing what your camera sees, but it's not always ideal for checking focus on your subject, because if you're shooting at a very shallow depth of field, it's sometimes so shallow that in that viewfinder, you can't really tell if the part of your subject that you want to be in focus is actually in focus. So there's accessories that you can buy, like focus magnifiers or focusing screens that you can put inside your camera, and they'll help you check that focus a little bit better, but they're still not ideal. Another problem with optical viewfinders is, remember that we said when you're using that, you're using a phase detection autofocus system, and that autofocus system is a completely separate system from what you're seeing coming through the lens. So why is that a problem? Well, if your autofocus system is off a little bit, you will have no idea when you look through the lens that your final image might not actually be as sharp as you think it is when you're looking through. So that's just one thing to keep in mind. It's not necessarily something that you're going to run into all the time, but it's a very definite possibility that could be a huge issue if you ever encounter it. Now with live view, that is a contrast detection system, so it is exactly what your camera's sensor is seeing and exactly what your final image is going to look like. So when you check your focus in live view, you know that you have the ability to zoom in, you can view your image at a 1:1 magnification, and you can check to see if the exact part of your image that you want to be sharp is sharp. So that's a great benefit to live view. Live view is probably not the ideal method to use for focusing on a DSLR, because when you use live view, you're moving your camera away from your body and you're pushing buttons and you're zooming in and you're checking focus. And once you do that, if you're photographing anything that moves like wildlife or a person, well, you've probably already lost focus or they have moved on to do something else. So it's a great technique to use for landscapes or for products, and it's actually a recommended technique because you can nail your focus. But you have to make sure that your camera's on a tripod, because even if you're holding your camera out here and your subject's not moving, it's going to be a lot harder to hold your camera stable unless it's on a tripod. Now we set up this demonstration so that you can see exactly how powerful live view is when you're focusing on your subject. Now with the traditional viewfinder that's optical, you are limited to the point of view of your lens. So you can't zoom in and check for focus on your subject. With a live view, you can actually zoom in and check to make sure that your subject's in focus before you take the image. So I'm going to show you how that works. So right now you can see I don't think this image is very well focused, so I'm going to go over, and what I'm going to do is zoom in. I move my focus point to the sailboat. I'm going to zoom in, and you can see it is not in focus. So when I focus, camera's acquired focus, and you can see that boat looks very sharp now. Now, if you have a lens that doesn't autofocus with your camera, you can still use live view. And let's say your image is way out of focus. I can just turn the focus ring, and then I can check to make sure that my subject is in perfect focus. So you can see this is very useful when you're focusing on distant landscapes, on scenes that aren't moving, and that's an important part. If your subject is moving, if there's fast action, you don't have time in live view to zoom in, to get focus, and take the image. You'll want to rely on your camera's normal autofocus in those situations. But for a landscape or for a scene like this, using live view to get perfect focus is a great idea, and it works very, very well. Now you'll notice I didn't say anything about mirrorless cameras like this one I've been holding the entire time, and there's a reason for that. They don't have optical viewfinders. Instead, they have what's called an electronic viewfinder. In an electronic viewfinder, the image that is projected into your viewfinder is the exact same thing that's hitting your camera's sensor. It's the same with live view. If you switch this between live view and you look through the viewfinder, you're going to see the exact same thing, and it's just a digital image. There's no optics involved like there is with an optical viewfinder. Now, the great thing about using an electronic viewfinder is that before you take your picture, you can actually set it so that you push a button on the back of the camera, and that projected image in the viewfinder can zoom to 1:1. So you can check whatever your camera is focused on. Make sure it's in focus before you take the image. If it's not, you can refocus. If it is, you can go ahead and take the picture. The really neat thing is there is no delay like there is when you use live view in a DSLR. In a mirrorless camera, there is no mirror to move up and down, so taking a picture is instantaneous whether you're in live view or looking through the viewfinder. When you take a picture with the DSLR, in order to review the image that you just took, you have to pull it away from your face, look at the screen, and then you can see the image. But if you're in a very bright environment, like a really sunny day, that screen can be near impossible to see. Well, with a mirrorless camera, it's really, really cool how it works, because since you have an electronic viewfinder, you can actually immediately see the image that you just took in the viewfinder. You don't have to look at the back of the screen. So the really nice thing about that is if you're shooting in a sunny day and you want to take a look at your image that you just took, all you have to do is keep your eye up to the viewfinder and you can review the image right there. Doesn't matter what the conditions are. If it's really sunny, you'll still be able to see the image. So if you're considering buying a new camera and you can't decide whether you want a DSLR or a mirrorless, these are just a few of the things that you'll need to keep in mind when you're making that decision.